Hello everyone, I am Olatoye Michael Oluwadamilare, a 100-level physics education student from Lagos State University. Today I am excited to share with you my knowledge on an interesting topic, radioactivity. Our learning objectives for today are number one, meaning of radioactivity. Number two, meaning of radioactive element. Number three, meaning of half-life. And number four, solving problems related to half-life. It implies that by the end of today's video, we should be able to know the meaning of radioactivity. We should be able to also know the meaning of radioactive elements. We should be able to define half-life, and we should be able to solve any problem related to half-life. To start with, what is radioactivity? We need to know the meaning of the word radioactivity. Radioactivity is a spontaneous decay of an unstable nuclei of the atom of an element with the emission of alpha, beta, and gamma radiation with the production of energy. Now, according to the definition, we were made to know that radioactivity is a spontaneous. So we need to know the meaning of the word spontaneous. Spontaneous means naturally. Something should occur naturally. So spontaneous means naturally. Now, what's the meaning of the word decay? Decay means something should split, die. So it means there is a particular atom. You know, we were made to know that nucleic of an atom. So it means the word unstable means it is not balanced. They said radioactivity is the word spontaneous. Spontaneous means natural. Decay means it should split. Of an unstable. Unstable means it is not balanced. Nucleic. The meaning of the word nucleic means it is the plural form of nucleus. So it means, and we all know that nucleus is what? Inside of an atom or inside of a cell. We call it cell in biology, and we call it cell in what? We call it atom in chemistry. So it means there is a particular nucleus of an atom that is unstable. So the splitting of it is radioactivity. So now, which elements, because we were made to know that they said nucleic of an atom. So it means there are some atoms that are unstable. It means their nucleus are not stable. So which elements undergo this radioactivity? That will lead us to what is called radioactive elements, which is our second objective. Radioactive elements. According to the note, we said we are going to explain radioactivity, also radioactive elements. So what is the meaning of radioactive elements? Radioactive elements are elements that undergo radioactivity. So it means their nucleus are not stable. So where can we find these elements? They are found in period 6 and period 7 in the periodic table. Actinides, we call them actinide and lactanide elements. So examples of these elements are uranium, radium, thorium, etc. So as we said earlier, according to the definition of radioactivity, we made to know that what? There are some particles that are emitted, which are alpha, gamma, beta, and also energy is also released. So let us see the way the equation normally looks. So let's see the first equation. We have radium 22688. It split and it gave us radon 222 86 plus alpha particle, which is helium, which is 4,2 plus theta. This theta is the energy released. So this one is what? Emission of alpha particle. Let us see equation whereby beta particle is being emitted. We have thorium, which is 234. We have thorium 234 90 to give us palladium, which is what? 234 91 plus electron, which serve as beta, which is -1 is 0 plus theta. This theta also serve as what? The energy. And let us see the third equation, which indicates what? Gamma being emitted. We have proton plus deuterium to give us helium with mass number 3 and atomic number 2 plus gamma that is emitted plus theta, which serves as our energy produced. So now we move to something known as half-life, which is the third objective. The meaning of half-life. What is half-life? Half-life is the time taken for a radioactive element to decay. The word decay means split. As we said earlier, disintegrate. Some other person can say disintegrate. So what is the symbol for half-life? This is the symbol. T subscript half. So we have two formulas for now for half-life. We have some formulas for half-life. And the first formula is this. Half-life is ln 2 over lambda. Now, this ln 2, once you press your calculator, is the same as 0.693 all over lambda. As we said earlier, this is half-life. What is the meaning of this lambda? It is called decay constant. And the symbol is this, why the unit is per seconds. This is the first formula. You can say equation 1. The second formula for half-life is N over NO equals to 1 over 2 all raised to our small letter n. Now, this small letter n, let's say this is equation 2. This small letter n is T over half-life. Now, we need to know the meaning of this capital letter N. This N subscript O, this small letter N, this small letter T, and we already know this one already. So let us know the meaning of them. Our capital letter N is life left. Our N sub O is the original life. Our small letter T is the time expected in the reservation. And our small letter n is the number of time a radioactive element decay, which means the numbers of time it disintegrates. So let us see some questions concerning half-life. Let's see the first question. We have about 4 examples we need to examine today. So the first example goes thus. What is the half-life of a radioactive element whose decay constant is 0.231 per second? What is the half-life of a radioactive element whose decay constant is 0.231 per second? So it means, according to the first example, we are to look for the half-life. Now, they give us the decay constant as 0.231 per second. So according to the two formulas given to us, we are going to use the first formula. Why? Because they gave us two entities. So it means we are going to use the first formula, which says half-life is 0.693 over decay constant. And we know that our decay constant is 0.231. So if we press our calculator, we are going to get 3 as our answer. So we say 3 seconds. We move to example 2. The half-life of a radioactive element is 3 days. What fraction of its original value is left behind after 6 days? The half-life, according to the question, is 3 days. The time expected in the question is 6 days. So, as we all know, so according to these two things given to us, we should know that we cannot use Formula 1. Because in Formula 1, we need in Formula 1 is only half-life we have. There's nothing like small letter T in Formula 1. So we are going to make use of Formula 2. So before we proceed now, because they gave us 2 time, so it means we need to look for the number of time the radioactive element decay, which is small letter T over half-life. That will give us 6 over 3, which is the same as 2. So if that is the case, and the second formula says n over NO equals to 1 over 2 all raised to power n, which is the same as n over NO, which is 1 over 2 all raised to power. Our n is already 2. If it is 2, n over NO equals to 1 over 1 raised to power 2 is 1, while 2 raised to power 2 is 4. If we are to cross and multiply, our n will be 1 over 4 NO, which means the life left is 1 out of 4 of the original life. That's the solution to question 2. The question says, what fraction is left after 6 days? So it is 1 out of 4 that is left behind. Let's see the third question. The third question goes thus. A radioactive element has half-life of 12 days. What fraction of its original life will have decayed after 48 days? Unlike the second question, this second question says left behind. But this third question says the one that has decayed. Decay means the one that has gone. But this one is the one that is still remaining. So it means the two questions are somehow similar, but they are somehow different. So let us read the second question once again. A radioactive element has half-life of 12 days. So it means the half-life, now question 3. The half-life is 12 days. And the time expected in the question is 48 days. So we have to look for the life that has decayed. We are still going to make use of the second formula, which is n over NO equals to 1 over 2 all raised to power n. So let us go and look for our small letter n, which is T over half-life, which is 48 over 12. So our small letter n is 4. So it means the radioactive element decay 4 times. So our capital letter N, we do not know, over small letter, capital letter this equals to 1 over 2 all raised to power. Our small letter n is 4. So we have something in this form. N over NO equals to 1 raised to power 4 is 1, and 2 raised to power 4 is 16. So once we cross and multiply, the life left will be 1 over 16 of the original life. So this is the life left behind. So, but we are not asked to look for the life left behind. Instead, we are to look for the what? The life that has decayed. So for us to look for life that has decayed, the formula will be original life minus the one that is left behind. Original minus the one that is left behind, which is 15 over 16 of the original life. Because this one is, we'll look for LCM and 16. Once we solve very well, we are going to get this. So it means 15 out of 16 is left behind, and 1 out of 16, 15 out of 16 has decayed, and 1 out of 16 is left behind. And it's somehow easy. In school, let's say someone scores 6 over 10. That is the passing mark. So if they say, how many did the person fail? The person will say 4 out of 10. Same thing here. Someone scored 1 out of 16. The person will fail 15 out of 16. So this is the life that has decayed, and this is the life that is left behind. Let us see one more question related to half-life. Question number 4. An element whose half-life is 10 days is of mass 12 grams. Full stop. Calculate the time during which 11.25 grams of the element would have decayed. An element whose half-life is 10 days is of mass 12 grams. Full stop. Calculate the time during which 11.25 grams of the element would have decayed. According to the question, the half-life is 10 days, and the original life, they said, of mass 12 grams, which means the original life is 12 grams. They said, calculate the time, which means we are looking for the time expected in the question, in the reservation, during which 11.25 has decayed. So if 11.25 has decayed, it means life that has decayed is 11.25 grams. So if 11.25 grams has decayed, let us look for the life left, which is ordinary N. So that will be what? The original minus the one that has decayed. What that has decayed. So if that is the case, our N equals to the original life is 12. Why the one that has decayed is 11.25. So if we are to subtract, we are going to get 0.75 grams. So this is the life that is left behind. So now, since we know the life that is left behind, we can now look for the what? Time expected for this to have been decayed. So the question says, calculate the time taken for 11.25 grams of the atom should have decayed. So if 11.25 has decayed, then 0.75 grams will be left. So it means we want to look for the time taken for this should be left. Initially it is 12 grams. So how long will it take it to have remained this? That's what we are looking for. So for us to do that, we are going to use the second formula. N over NO equals to 1 over 2 all raised to our N. Our N is 0.75. NO is 12 equals to 1 over 2 all raised to our N. 0.75 here 1, 0.75 here 16 equals to 1 over 2 all raised to our N. So if we are to use indices, that will be 1 over 2 all raised to power 4 equals to 1 over 2 all raised to power n. Because 1 raised to power 4 is 1 and 2 raised to power 4 is 16. So 1 over 2 becomes 1 over 2. Our n is 4. Now we know our n as 4. And we also know our half-life as 10 days. So now to look for our t will be very easy. So what is the formula we are going to use? N equals to T over half-life. Our N is 4 and our half-life is 10. So if we are to cross and multiply, our T is 40 days. So in 40 days, 10.25 grams will have decayed. So that is the end of the question. In summary, radioactivity is a spontaneous decay of an unstable nuclei of the atom of an element by the emission of alpha beta and gamma radiation with the production of energy, while radioactive elements are elements that undergo radioactivity. Also, half-life is the time taken for a radioactive element to decay, and we were also able to solve some questions related to half-life. Understanding this concept is crucial for grasping various phenomena in physics. Assignment. Let's see some assignments. Number one. A radioactive element has a half-life of 50 days. What fraction of its original life will have decayed after 200 days? Assignment 2. What is the half-life of a radioactive element whose decay constant is 0.17325 per second? Assignment 3. The half-life of a radioactive element is 13 days. What fraction of its original value is left behind after 52 days? Assignment 4. A radioactive substance has a half-life of 3 minutes. After 9 minutes, the count rate was observed to be 200. What is the count rate? What was the count rate? At 0 time. So, in our next class, we are going to consider this aspect of radioactivity. We are going to consider types of radioactivity. We are going to consider the particles emitted during radioactivity, and we are also going to consider the uses of radioisotope. Thanks for watching. I hope this video helped to clarify the meaning of radioactivity, the meaning of radioactive elements, the meaning of half-life, and you were also able to know how to solve some questions related to half-life. Don't forget to like, share, and comment. Thanks.